Okay, so in this video we're talking about how to solve exponential and logarithmic equations. Pretty much what we want to focus on in this video is that the bases must match when we're solving this type of equation, so keep that in mind. Alright, so let's go get started. Example 16, I'm going to do in green. Pretty much the bases need to match. So here I got base 4 and base 8. Well, obviously those don't match yet, so I want to try to think of a little bit of scratch work. How can I make those bases match? This might come easy to you, or you might need to use some scratch work in your calculator, but I know that both 4 and 8 can be rewritten with base 2. For instance, just scratch work on the side. 4 is equal to 2 squared, and 8 is equal to 2 cubed. Okay? So I'm going to rewrite my problem to start off with that. So I have 4, oops, not 4. Instead of 4, I want to write 2 squared. So I have 2 to the 3x, and that's squared. Okay? Now, here I have, and that's going to be equal to 8, which is going to be rewritten as 2 cubed. So 2 to the x plus 1 cubed. Okay? Now, what you should remember from previous class is that anytime you have a power to a power, you simply multiply the power. So that means for this problem, it now becomes 2, and I'm going to multiply my powers to the 6x, and that's going to be equal to 2, my base just stays the same, multiply the powers, because I have power to a power. So that's going to be 3x plus 3. As soon as you get the bases the same, what you can do then, if the bases are same, that means the powers have to be the same. So that would mean 6x is equal to 3x plus 3, and now we can solve very easily by getting, I'm going to take 3x and move it over to the left. So I have 3x equals 3, so that means x has to be 1. Right? Not too bad. The next problem, let's do it in purple. Okay, now here I have base 2 and 7. Well, I know that there's no way that I can get these bases to match. So now we have to do a new concept. We're going to actually, this is an exponential function. So like we said in previous videos, that exponential functions and logarithmic functions cancel out. And to make that happen, we have to have the bases must match. So since I have base 2 for my exponential function, then when I take my log to cancel it out, it's got to be log base 2. So what I'm going to say is log base 2 of 2 to the x equals log base 2 of 7. Remember, what you do on one side, you have to do to the other. So I'm taking log base 2 on both sides. Base 2 and base 2 are going to cancel out. So what that means, I have x equals log base 2 of 7. Now, I could technically stop there because I have x by itself. Or, if I want to do a little bit of scratch, or I can use the change of base rule that we talked about in the previous video, we say x equals log of 7 over log of 2, and then we can type that in our calculator and get a decimal. So let's do that. So log of 7 divided by log of 2. And so that this decimal, my x, is approximately 2.81. Okay? So whatever you want. Alright, and then the last one, let's do that problem in red. Now, I still have an exponential, 10 to the 2x minus 3, but I also have a plus 4 on that same side. So my very first step is to get my exponential piece by itself. So to do that, I'm just going to subtract 4 to start off. So I have 10 to the 2x minus 3 is equal to 21 minus 4, that's 17. Okay? If you are bad at that subtraction, pull up your calculator. Double check it. Don't let your pride and your ego get in the way. 21 minus 4, 17. It only takes an extra second, so Because if you make a mistake there, or something easy like that, because you let your pride get in the way, it's going to mess up the entire problem. So better take that extra time if you need it. Now, there's no way I can make base 10 and base 17 match up. So what I'm going to have to do is use a log on each side. So I'm looking at my exponential piece, which is over here on the left. That's going to tell me what base my log needs to be. So my base is 10, so the log has to be base 10. So I'm going to say log base 10 of 10 to the 2x minus 3 equals 17. Actually equals log base 10 of 17. Okay, well, base 10 and base 10 cancel out. So the 2x minus 3 falls down. And 2x minus 3 is equal to log base 10 of 17. Now, I'm still trying to get x by itself, but you might be intimidated by this log base 10 of 17. First off, the log base 10, that's called the common log, remember from the previous video, so I can just write this as log of 17. Because that base 10 is understood. And log of 17 is going to be a decimal. It's going to be a nasty, ugly decimal, so I'm just going to leave it log of 17 for now. Alright, so to get x by itself, I need to add 3. Add 3. Now, 2x is equal to. Now, do not say 17 plus 3 is 20. This 17 is trapped inside the log, so just bring everything down. Log of 17 plus 3. Okay, like that. Now, finally, we need to divide by 2 to get x by itself. Alright, so x equals. Now, again, don't say 17 halves. That's terrible. Don't do that. Just leave everything the way it is. Log base 17 plus 3 all over 2. So that's my answer. Now, I could go a little bit farther and punch this in my calculator and get a decimal. What I have to remember, though, if I'm using my calculator, I have more than one thing on top, so I'm going to put that in parentheses just to be safe. Okay? So let's do that. We can get our decimal. So I have log of 17, parentheses first, log of 17 plus 3, and then close parentheses on the end, and then divide by 2. And so my decimal, all of this mess right here becomes my final answer, which is x equals 2.12 if I round. Okay, and again, I'm rounding there 2 decimal places, no big deal. Essentially what we found is the base has to match up, the base of our exponent has to match up the base of our log that we're using. Okay, let's solve some equations that have logs to begin with, okay? So, again, the base must match. Do the first one in green. Well, my example 19, I have base 3, base 3. The base is already matched, so no big deal. If the base is matched, that means the inside pieces have to match. So I can start off by saying 5x minus 1 equals x plus 7. Again, I'm only able to say that because I have one log per side, and those bases are exactly the same, base 3 and base 3. If you have more than one log per side, or if the bases do not match, you can't do that, okay? So you would have to do more work, which we'll see in a few minutes. All right, so now this becomes just a regular equation. We'll get our regular numbers on one side, our x's on the other side. So I'm going to take x over to the left, negative 1 over to the right. So minus x plus 1 plus 1. I'm doing this all in one step. If you need to break it up into 2 separate steps, do that. All right, so 5x minus x is 4x. Negative 1 plus 1 cancels out. X minus x cancels out. And 7 plus 1 is 8. Alright, so now get x by itself by dividing by 4. So x equals 8 over 4, which is 2. Not too hard. Next problem, let's do that one in blue. Okay, I start off with one log per side, which is good. That's exactly what we need. But I have log base 5 of 3x plus 1 equals 2. There's no way I can have base 5 and 2 match up, same base. There's no way that's going to happen. So I remember back in the previous video, logs and exponents cancel out. Well, since I started with a log, I need to go use an exponent to cancel it out. This process is called exponentiating. It's just a fancy word. What I think of it as is I'm jacking my car up. So this equation represents my car, and I want to get underneath my car to work on it. So my car, I have to use a jack. I have to go up 5 little clicks on my jack. Okay, because base 5. So now my car is up in the air and I can get underneath it. Well, base 5 cancel out, so I'm just left with 3x plus 1 falls down, and that's equal to 5 squared. That's 2 is still up in the air. 5 is my base. Okay, so I want to clean this up as much as I can. I know 5 squared is 25, so let's go ahead and take care of that. And now it's just a regular equation that we can solve. So first step, minus 1, minus 1. So 3x equals 24, and get x by itself by dividing by 3. So I have x equals 24 over 3, which is 8. No big deal. All right, in our next problem, there's actually a typo. So right here on the left-hand side, please fix your notes if you're following along. There should be a plus sign in between these two logs. So I'm going to just rewrite the entire equation the way it should be. So update that in your notes. So log of 5x plus log of x minus 1 equals 2. Okay, so cross that out. That was a typo. That's my fault. I'll go back and fix it. But if you don't have it fixed in your notes, go ahead and fix it now before we start. Okay? Sorry about that. All right, so now, again, I only want one log per side. Well, your instinct might be like, well, we can add or subtract the log and take it to the other side. True, we could. However, what I would suggest you do is use the properties of logs that we talked about in the previous video. We have plus on the outside, so we know multiply and plus go together. If we have plus on the outside, that means we can multiply on the inside. So this piece actually can be rewritten as log of 5x times x minus 1, close my parentheses, and that's still going to be equal to 2.
Miss Smith, please call the front office. Miss Smith.
All right, so now I have distributed property on the inside. So 5x gets multiplied to both pieces on the inside of my log. So I have the bond of 5x squared minus 5x equals 2. Now, another thing you need to notice about this problem is that there's no base written down, so I have regular log. Anytime I have regular log, that's called the common log, like we talked about in the previous video, and its base is 10. So I automatically know that it's base 10. Well, to get rid of my log, I have to exponentiate on both sides. Again, this is like jacking up our car on both sides. Since the base is 10, I need 10 clicks on my jack. Okay, so let's go ahead and do that. I'll do that in purple. So base 10, base 10. Now my car is up in the air, but base 10 and base 10 are going to cancel out my log. So 5x squared minus 5x is going to fall down. And that's equal to 10 squared. I know 10 squared, though, is 100. So let's go ahead and change that. And now I have a regular quadratic equation like we've done before. So what I'm going to do is first get everything on the same side by taking 100 over to the left by subtracting. And just combine like terms. So 5x squared minus 5x minus 100 equals 0. Now I want to factor, again, like I've said many times before in this set of videos. If you're bad at factoring, please check out earlier videos, okay? Because factoring is one, it's a skill you should know already from previous classes. And two, we've already talked about factoring in this class, so you should be okay at that by now. All of these have a multiple of 5, so I can pull a 5 out. And I'm just left with x squared minus x minus 20. That's equal to 0. And I'm going to divide by 5 on both sides to get rid of that. And when I do that, I'm left with x squared minus x minus 20 equals 0. And now I'm ready to start factoring this some more. So I'm looking for factors of negative 20 that add up to negative 1. So again, if you struggle with factoring, I understand factoring is not easy. I wasn't good at it in high school, but you really need to overcome that hurdle. So this becomes x minus 5 and x plus 4. Let's do our double check. Negative 5 times positive 4 is negative 20, and negative 5 plus 4 is negative 1. So we did our double check, so these are both good. Now this is still equal to 0, so don't forget that. And since I have my factors equal to 0, I can now use what's called the zero product property, which simply means I can take each factor and make a smaller equation out of them. So x minus 5 equals 0, and x plus 4 equals 0. Alright, so now what I want to do is say plus 5, plus 5. So this one tells me that x equals 5. Now, minus 4 for the second equation, minus 4. So this one tells me x equals negative 4. Okay, and that's it. So in this video, again, the bases must match. Whether you're have an exponential equation that you're having to take a log on both sides, or you start off with a log equation that you're having to exponentiate on both sides. The base must match every time. This one takes some practice, but I'm sure you can get it. Let me know if you got questions.